Number 8 on our outline is a pretty difficult problem. This is more AP level on this problem, but we're going to go through it because knowing the concepts on it is going to be very helpful. So suppose you have a used car dealer that runs autos through a two-stage process and gets them ready to sell. So the mechanical checkup costs $50 per hour. It takes an average of 1.5 hours, and the standard deviation of 0.25. So, it takes about an average of an hour and a half, give or take a quarter of an hour. The appearance prep costs $6 an hour and takes an average of 1 hour with a standard deviation of 0.083. So there's a lot going on here, and I'm going to kind of piece by piece figure this thing out. So the average checkup time would be what? So checkup time was $50 per hour, and it takes an average of 1.5 hours. So 1.5 would be the average checkup time. The standard deviation of checkup time would be 0.25, which is what they tell us right here, standard deviation of 0.25. Now let's look at the appearance prep. The appearance prep takes an average of 1 hour. So that would be 1, because our first question is what are the mean and standard deviation of the time? So the time means we need to be focusing on the time here. So I'm getting all the mean and standard deviations of each time. So the standard deviation of the appearance time is 0.083. 0.083. So can I figure out the average for the mean, the average of how long it'll take to do the car? I can, right? I just add up the two averages, 1.5 and 1. So if it takes an average an hour and a half to do the checkup and an hour to do the appearance, it would be 1 plus 1.5, which is 2.5 hours. So 2.5 on the total time on that one. So the standard deviation, remember, I can't just add them together because they're two separate events, right? So I have to do that Pythagorean theorem, which is 0.25 squared plus 0.083 squared. And when I do that in a calculator, let's pull up a calculator and figure that out. The square root of 0.25 squared plus 0.083 squared. And I get 0.263418 as my answer. So 0.2634, we'll go 4 decimals on that one. You can go 3 if you want to, and I would count that right. So there's my standard deviation for the total time. All right. Now they want to talk about the expenses of the car. And to figure out the expenses, if it's $50 an hour, and it averages 1.5 hours, the average checkup cost will be the $50 times the 1.5 hours. $50 an hour times 1.5 is $75. Now the average for the appearance cost is $6 an hour for 1 hour. 6 times 1, $6 an hour times 1 hour is $6. All right, so the standard deviation of the checkup cost would be, let's see, we've got 0.25 hours is what it would take, right? So it takes 0.25 hours, $50 an hour. So you would do 50 times 0.25, which is 12.5. And for your appearance cost, it would be $6 per hour, $6 times 0.083. It takes 0.083 deviation. So 6 times 0.083. So 6 times 0.083 in a calculator. It's going to give me 0.498. All right. So can I calculate the total expense? The average total expense. So the mean of the total, let's go over a little bit. We'll move over right here. The mean of the total would be the two total averages added up, right? It averages $75 for the checkup and $6 for the appearance. So 75 plus 6 equals $81. So it averages $81. 81. The standard deviation total would be you add these two up in Pythagorean, so it'd be square root of 12.5 squared plus 0.498 squared. So let's get that in a calculator. The square root 12.5 squared plus 0.498 squared is 12.5099 or 12.51. So we'll call that 12.51. So our standard deviation on the cost is $12.51. All right, so we figured out B. So those were the two tough ones to really figure out here. And for C, they want to figure out the mean and standard deviation of the difference in cost. So for the difference in cost, it would be, you just subtract the two costs, 75 and 6, for the mean. Remember, the mean, you just plug them in, basically. 75 minus 6 equals $69 on average. Now, for the difference of the standard deviations, remember, you use this same formula, and you still add, no matter if you add or subtract, so it's actually going to be the same answer as this last one. So for the standard deviation, it's just going to be the square root of 12.5 squared plus 0.498 squared. And that's the same answer we got earlier, 1251 will be the answer to the standard deviation here. So it doesn't matter if you add the two together, like we added on B, or if you subtract the two, like on C, you're going to get the same answer for the standard deviation. Obviously, the mean will be different, but the deviation will not change. 12.51 on both. All right, so what is the probability that it'll take longer than 2.7 hours to do the prep and mechanical checkup? So we're looking back at the time ones. So our mean for the total time, back on A, we figured that out, and it was 2.5 hours. And our standard deviation for the total time was 0.2634 hours. 0.2634. So if I know mean and standard deviation, I can use what I learned in Chapter 5, and that is if you have a normal distribution, which these will be, if you have enough data, they're going to be a normal distribution. What you can do is use your normal distribution calculator to calculate the odds of getting longer than 2.7. So what is the probability that the time will be greater than 2.7? So we know that the average time is 2.5, and the average, the standard deviation of the time is 0.2634. So what are the odds it's going to be greater than 2.7? It should be a little less than 50-50, right? Because on average it's only 2.5. So greater than 2.7 should be a decently low number. Let's go ahead and calculate it in Staplet now. So I'm going to bring up Staplet, and pause if you need to. So I'm going to do a normal distribution. This is the only other, you'll be using these two right here, discrete, random, and normal on this test. So normal distribution. And you're going to use area under the curve. We're not going to do that other one on this test. It's going to be area under the curve. So our mean was 2.5 hours. So we put that in, 2.5 hours. And our standard deviation was 0.2634. 0.2634. And I plot the distribution. And, this is what the normal distribution looks like. You might remember that. And 2.7 is like right here somewhere. So it's going to be the curved, the shaded to the right of that curve. So it's going to be a decently small amount. It's going to be definitely less than 50, right? If they asked what is the odds it'd be less than that, you'd do the left. But greater than is to the right of that value. And they asked for greater than 2.7. So to the right of 2.7 means greater than 2.7. So we're at 2.5, and what are the odds are going to be greater than 2.7? I calculate the area, And there's my area right there. And as I guessed, it was definitely a lot less than 50. It's 22.38% chance of that happening. So this is going to be a 22.38% chance that it will take longer than 2.7 hours. 2.7 hours. All right, and that is E. Pretty difficult question. It won't be one quite that hard on your test, because I think of that as more of like an AP level question. But as long as it's good to know these concepts though. So that is number 8.